Okay, on to describe in more detail multimode fiber. So in general, modal dispersion is what's determining the performance of our multimode fiber in as much as the bandwidth distance product is concerned. And it turns out that over the years, what they've done is they've used multimode fiber in the data center, and as I've mentioned, it's normally 850 nanometers and 1300 nanometers are the wavelengths that are used. And over the years, instead of just specifying the physical properties of the fiber, they've actually moved to measuring the bandwidth distance product of the fiber and specifying that. Okay, and so the bandwidth distance product, B times L, is what we've dealt with so far in Chapter 3, for example. In the summary of Chapter 3, they're giving an F3 dB times L value. These are the bandwidth distance products. Okay, so our notation is different, but you're always going to find different notation. And there's several different types, depending on what they call the EMB, the effective modal bandwidth. And it really is just a bandwidth distance product. And here you can see that it has the right units. Megahertz kilometers are the units on this. EMB is what they call effective modal bandwidth. And it's a modal bandwidth because it's determined by that modal dispersion. So there are four types, OM1, 2, 3, and 4. And they have increasing performance specs. And so they're all specified at 850 nanometers. And they're all specified for a type of laser called a VCSEL. And a VCSEL is short for a vertical cavity surface emitting laser. It's a very low cost 850 nanometer laser. And the advantage of it is that it has that very small spectral width like lasers do. So it doesn't have this broad spectral width like an LED, but it has the same sort of cost as an LED. So it's great. It has high bandwidth distance product, and it's very cheap like an LED, and so it has really taken over the applications in the data center for multimode fibers. So all of these multimode fiber types are specified at 850 nanometers for a VCSEL, and the bandwidth distance products go from in the range of several hundred megahertz kilometers for OM1 up to several thousand, up to 4,700 megahertz kilometers for OM4. Okay, and the megahertz kilometer values are something that it's very easy to think in terms of 1 megabit per second per megahertz of bandwidth. Okay, think in terms of the spectral efficiency, and so for every hertz of bandwidth, think in terms of getting 1 bit per second out of that. And so, for example, if we have OM2 fiber that's spec'd at 1,000 megahertz kilometers, 1,000 megahertz is 1 gigahertz, and so roughly a gigabit per second over 1 kilometer link. If you want to do a 10 gigabit per second link, you'll have to go down to 100 meters. Okay, we go 10 times as fast and we only go 1/10 as far. So 1 kilometer for a gigabit per second and 100 meters for 10 gigabits per second. And so this effective modal bandwidth specification is given on these fibers. It really comes from what Corning calls differential mode delay. It's what we have been calling modal distortion in our language. Okay, that's what our author Peleus calls it. And what I'll do now is I'll just show you, I'll show you another slide that, I'll show that slide in the next video. What I want to do now is I want to show you the Infinicore 62.5 micron fiber spec sheet from Corning. And the Infinicore, the thing they say here is, how do you measure trust? Well, how do they specify this fiber? They specify in terms of gigabits per second over some distance. And so there's two different types of Infinicore fiber. I hope you can read this in the video. We've got the CL1000 and the 300, and it specifies 1 gigabits per second over 500 meters at 850 nanometers. They also give a specification for 1300 nanometers, and these are for lasers. And so you can see then that they've specified the data rate over a certain distance. In other words, they're giving you the bandwidth distance product. The standards compliance, the simplest way of describing these fibers, their standards, is OM1, OM2, OM3, OM4. And that OM distinction comes from the ISO standards. But there's also IEC and TIA, EIA standards, which are essentially running parallel to the ISO standards. So for our purposes, we just say OM1 fiber. Okay. And here it gives you optical specifications. It actually gives you the EMB values, megahertz kilometer values, okay, specified at 850 here. And I guess they're calling the Infinicore 300 the legacy fiber, and the Infinicore CL1000 the intermediate performance EMB. And you can see their bandwidth distance products here. And so that's an idea on the multimode fibers, and I'll give another video on multimode fibers just now. Thanks.